Alright, so today we're going to do section P2, which is on simplifying with exponents. So we'll work through several problems together where we're using exponent properties. And so exponent properties you were probably introduced to the first time in middle school. We've done them in Algebra 1, Algebra 2. They are something that gives a lot of people trouble though. So just to go back over what the basic properties are. The exponent property of 1 just means that if your exponent is 1, then you get that same number back. So the example that's up here is 5 to the first power is 5. The exponent property of 0 is if your exponent is 0, then you get 1. So 7 to the 0 is 1. And in case no one has ever explained why that is, if I had 7 squared over 7 squared, that would be 49 over 49, which is 1. But also if you use the property that's down here, this quotient property, then you see, no, that's the wrong one. Where did it go? Oh, it's this one. That's in a weird place. I said quotient property and then I didn't circle the right one. Sorry. If you look at this one, you're going to subtract those exponents. So that would be 2 minus 2, which is 7 to the 0. So because it's something divided by itself, then that's why it equals 1. All right, so the next one is the negative exponent property. So if I have a negative exponent, all that does is move to the denominator. If I had a negative exponent in the denominator, it would move it to the numerator. We're not supposed to have negative exponents, so we have this rule to be able to fix it. All right, so the example is if I have 4 to the negative 2, that's the same thing as 1 over 4 squared, or 1 over 16, because 4 times 4 is 16. All right, so we have a product property that says if we're multiplying two like bases together, then we can add their exponents. All right, so here we're multiplying like bases of 3, but they have exponents, so we can just add those exponents. And if you think about this one, it makes sense too, because this is literally saying there's 2 3s, and this is saying there's 4 3s. And you can see that there are 6 3s. All right, so next we have the power of a power, which means you're going to take something that has an exponent and raise it to another exponent. And in that case, you just multiply those two exponents together. All right, so this is a slightly more complicated. 2 is going to happen 3 times, so it'll be 2 times 2 times 2, so 2 to the third, which is 8. X happens twice, but that happens 3 times, so there are 6. 3 times 2 is 6. And then you have this y that's going to happen 3 times, so you have 3 y's. So these properties are really just a way for you to not have to write this big old step out. You can jump straight from this to this. All right, our next property is the power of a quotient. So that's where you have something being divided and raised to a power. And that works kind of like the distributive property. Everything on top, everything on bottom gets raised to that power. So we have x divided by 3y squared raised to the 4th. Well, that's x to the 4th is the numerator. 3 squared. This is not, oh, it's to the 4th. Mercy. Lord help me. So we have 3 to the 4th, which is where this 81 comes from, because if you do 3 times 3 times 3 times 3, you get 81. We have y squared to the 4th, so it would be y squared, and another y squared, and another y squared, and another y squared, which gives you 8 y's altogether. All right, so the power of a product. That's the same concept as this one, except that you're multiplying. So exponent on the outside goes to the things on the inside. So we're going to square this guy. That'll be 3 squared, which is 9. X squared, which is x squared. And then y to the third squared, which is y to the 6th, because you multiply those exponents. All right, and then this quotient property is saying if we are dividing like bases, we can subtract their exponents. So here we have x's. So if we divide, we're going to subtract, or you can think there's 2 on the bottom, we can knock 2 off the top, and those just cancel. Like if you wrote it out the long way, then you know you can cancel those off. There's 3 left, but you can just subtract. That's a shortcut. If you look at this one, we have 3 on top and 9. 1, 2, 3, 4, 5, 6, 7, 8, 9. So you can take 3 of them off, and you would have 6 left. I think I crossed out too many. Let me redo that. Let me give myself some more space so I can actually see what I'm writing, and we'll redo that one. So again, 3 on top, 6 on bottom. That's a 9 on bottom. 1, 2, 3, 4, 5, 6, 7, 8, 9. I'm going to cross out the ones that are convenient. And then you see you have 3, 4, 5, 6 left, and they're all in the bottom. So it's this, which is the same thing as if I write this, because if I just subtracted these, I would get -6. But they're on the bottom, so I have to slide it to the bottom, which helps make that negative exponent rule make more sense. All right, so those are all of the properties. You will have some questions on your assignment that are nice and basic, like these. You'll have some questions on your assignment that are only number related. So like if it asks you to do, let's say -2 to the 4th, then you can work that out. So first of all, since there's no parentheses, the 4 only goes to the 2. So it's like there's parentheses here since they didn't put them. So we're going to say keep the negative and then do 2 multiplied 4 times. So what is that? 2 times 2 is 4, times 2 is 8, times 2 is 16. So it would be -16. Okay, if they wrote it like this, then it'd be -2 times -2 times -2 times -2. So it'd get a +16. This would be +4 times -2 is -8 times -2 is +16. They may be as simple as, can you do x to the 5th over x squared? So remember that that's just subtract those exponents. They could give you something as simple as 3 squared to the 3rd. So that would be 3 to the 2 times 3, so 3 to the 6th. And you can leave it like that, or you can use your calculator at this point and do 3 to the 6th power and get an answer. All right, so some of them are going to be nice and straightforward and simple. And then they're going to get more complicated where they look a little more like these. All right, so people have a hard time understanding what's meant by simplify. How do I know that I'm done simplifying? Like, we know that it means to make it look nicer, but we're not sure when we're finished. So up here in this yellow box, you know that you're done simplifying exponents when you have no parentheses, each base only appears once, and you have no zero and no negative exponents. All right, so the other thing to keep in mind is you may work the problem in a slightly different order than I do, because the order of operations applies, but if you do them a little out of whack, you can still get the right answer. So when you look at the problem, you just have to see what do you think needs to be done first. So if you look at this one, there's nothing to do inside the parentheses. So we're going to handle this to the 4th power. So we're going to do -2 to the 4th, x to the 3rd to the 4th, and y to the 4th. I don't need you to show me this step. I'm just trying to make sure that you understand what's happening. All right, so I do -2 to the 4th. That's -2 times -2 times -2 times -2, which is +16. Here we're going to multiply those exponents because you have a power raised to a power. And then y to the 4th is there, and you're done. All right, number 2, there's nothing you can do inside the parentheses. There's no exponent on the outside of the parentheses. So this is a simple multiplication problem. And so you're just going to multiply like parts. So -7 times -2 gives us 14. X squared times x to the third gives us x to the fifth. You just add those exponents because it's multiplying. And then y to the 8th times y to the -8th would be y to the 0, which is just 1. It's like it's saying there are no y's there, so you just leave them off. All right, number 3. We have division. So I'm just going to divide like pieces. So -4 divided by 2 is -2. X to the third divided by x to the fifth. If you subtract, you get -2. So remember, there's more on the bottom than there are on the top. So those leftover x's are going to go in the bottom where there were more of them. Here, when you subtract, you get 3. There's more on the top, so that's where they go. All right, number 4. We're going to simplify on the inside first. So if I divide 54 and 6, I get 9. Y doesn't have anybody to divide, so he stays. For the z's, we're going to say that 7 minus 2 is 5, and there were more on top, so they stay on top. All right, that's all still to the -2. All right, so the negative exponent means that it needs to go to the denominator. So we're going to say 1 over that whole thing. And it's to the +2 now. So the point of putting it on the denominator was to give us a positive exponent so we can handle it. All right, so now we're just going to square everything on the denominator. So 9 times 9 is 81. Y is squared, and z to the fifth is squared. Remember, you multiply existing exponents by new exponents, and you get 10. Okay, number 5. All right, so again, inside here, we're going to simplify. So divide the regular numbers. -30 divided by 10 is -3. 14 minus 17, because you're dividing those like bases of a, you're going to subtract those exponents, and that's -3, but it's in the denominator. Because it's negative, it goes to the denominator, or you can see that 17 was the bigger number, so that's where those 3 leftovers should end up. All right, here you have a negative, so remember the negative means bring it to the top, which would put b squared here instead of here. And you have 8, 9, 10, so b to the 10th. All right, that is to the third power. If you don't think bring this to the top, if you just do 8 minus -2, you're going to get 8 plus 2, because minus a negative means add, so you still get the 10. All right, so now to handle to the third. Everything is going to be done 3 times. So -3 to the third. -3 times -3 times -3. So that would be -27. Multiply existing exponents by the new one, so that would be b to the 30th and a to the 9th. All right, and this last one, remember we have that property that says anything to the 0 power is 1. So this big ugly thing is all raised to the 0, so it just equals 1. All right, so something else that people tend to mess up on is if I have something like 2x to the -3, there are no parentheses saying all of this is going to be to the -3. This -3 is only attached to the x unless there are parentheses. So this problem, you're going to get 2 over x to the third, because that -3 only sends the x to the denominator. But if it looked like this, then -3 goes to both of them. So they would both slide to the denominator and be cubed. And you would end up with 1 over 8x to the third. All right, so I know that's not a whole lot of examples, but that covers all of the different things that you're going to have to be able to do. So work on your assignment, and if you get really stuck, email me and let me know, and I will be happy to work some more examples or to work out a homework problem to help you get unstuck. Also, remember that the answers to the odds are in the back of the book, so you can look that up to see if you're on the right track. I'm happy to help, though. Please call or email if you need help. All right, that's the assignment. It's also in Google Classroom, so you probably already saw it.